can be equal to 0 an z minus z naught whole to the power of n for modulus of z minus z naught is less than sum r is the radius of the circle. Okay, and z naught is the center of the circle. Now, when the function f of z is analytic at z equal to z naught, then the function f of z can be represented as f of z is equal to summation n equal to 0 to infinity a n z minus z naught whole to the power of n for modulus of z minus z naught is less than r, where r is the radius of the circle. So we can write it as where an is equal to we know the notations 1 by 2 pi I integral over c f nth derivative of z naught, f nth derivative of here an is equal to 1 by n factorial f nth derivative of z naught f nth derivative at z naught. Okay. So we can expand, this is the expansion of f of z. So in this case, we can write f of z is equal to, first term is a0, second term a1 into z minus z naught plus third term a2 into z minus z naught whole square plus and so on. This is called Taylor's series. Taylor's series about z naught, about z equal to z naught. If we replace z naught by 0, if we take z naught is equal to 0, then this then we can represent f of z as f of z is equal to a0 plus a1 into z minus z naught. Z naught means here 0, a1 into z plus a2 into z square plus and so on. Okay, this is called Taylor series about origin. Okay, we are taking z equal to z naught is equal to. This is called the Taylor series about origin, and it is called Maclaurin series. Okay. According to, by the use of Maclaurin's and Taylor series, we can expand the function. For example, if you take f of z, if we take f of z is equal to e to the power of z, then this can be expanded as we can find f of f dash of z naught or f of 0, that is 1, and f dash of z naught is e power z, and f dash of 0 is equal to also 1. And we can use the Maclaurin's series. We can expand. Simply I am direct writing and to remember the expansion of e to the power of z. That means f of z is equal to, directly we can write as we discuss in real analysis. F of z can be represented as 1 plus z by 1 factorial plus z squared by 2 factorial plus z cube by 3 factorial plus and so on. I am taking the nth term here, that is z power n by n factorial plus and so on. This is a expansion of e to the power of z. Okay. So we can write f of z is equal to this as summation n is equal to 0 to infinity z power n by n factorial. This is z whole to the power of n by n factorial. This series converges for modulus of z less than infinity. That means this is exists for modulus of z less than. That means the entire real line. That means minus z is a complex number, modulus of z is a real number, so that we can write minus infinity is less than z is less than infinity. Okay, so it is z is lies between minus infinity and plus infinity in this disk. So this is the expansion of f of z. Okay, absolutely we can say that e to the power of z is a analytic function at everywhere, so that it is an entire function. Simply we can say that entire every polynomial, it is a polynomial, so it is an entire function. This is the expansion of e power z. Okay, now we can remember this. Similarly, from if we take f of z is equal to e to the power of minus z, just replace z by minus z. So then f of z can be represented as 1 minus z by 1 factorial plus z square by 2 factorial. Even terms are positive, odd terms are negative. Z cube by 3 factorial. Here 1 means z power 0 by 0 factorial. 0 factorial is 1. Z power 0 is 1. 1 by 1 is 1. That's why it is also even. Even terms are positive, odd terms are negative. Z power 4 by 4 factorial minus and so on. This is the expansion. So we can write in summation notation, f of z is equal to summation n is equal to 0 to infinity minus 1 to the power of n into z power n divided by n factorial. Okay. When we take n equal to 0, positive number. When we take n equal to 1, negative number. Okay. Similarly, this is the expansion of e to the power of minus z. Okay. You have to remember the expansion of e to the power of z and expansion of e to the power of minus z also. Similarly, we can remember sin z and cos z also. Okay. So as we know that sin z is a odd function, is an odd function. So if we take f of z is equal to sin z, then f of z can be represented as the expansion form by Maclaurin's series. You can write z minus z cube by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial and so on. Okay, I'm writing z power 7 by 7 factorial plus and so on. Okay, this is also valid for modulus of z less than infinity. So we can write it as, that means here f of z is, have to remember f of z expansion కాదు ఇది sin z. f of z అంటే sin z తీసుకున్నాం. కాబట్టి మీరు ఇలా here to write e to the power of z. This is the e to the power of z. E to the power of z is equal to summation n equal to 0 to infinity z power n by n factorial. Similarly, here e to the power of minus z expansion, summation n is equal to 0 to infinity minus 1 to the power of n divided by into z power n divided by n factorial. This is the expansion of e to the power of minus z. Okay. So similarly, we can expand sin z. If we take f of z equal to sin z, then f of z equal to this form. So we can write sin z in summation notation. Summation n is equal to 0 to infinity minus 1 to the power of n. Alternative plus and positives and negatives are there. That's why I'm using minus 1 to the power of n. And the powers all are odd numbers. That's why you can write z power 2n plus 1 divided by 2n plus 1 factorial. Okay, I'm writing it is expansion of sin z. Okay, direct question అడిగాడండి ఆల్రెడీ మీకు టెస్ట్ లో ఇచ్చాను, నేను ప్రాక్టీస్ టెస్ట్ లో ఇచ్చాను. ఓకే, అండ్ ఆల్సో వీ కెన్ రిప్రజెంటెడ్ sin z as ఇలా కూడా రాసుకోవచ్చు. సమ్మేషన్ ఐఎమ్ స్టార్టింగ్ ఫ్రమ్ 1 to infinity ఇలా కూడా అడిగాడు క్వశ్చన్, minus 1 to the power of minus 1 to the power of n minus 1. This when we take n equal to 1, it will be 0. Power 0 means 1. Okay, first term vasthundi. Z power 2n minus 1. The another form of odd number is 2n minus 1. Of course, 2n plus 1 is also an odd number. Here, denominator is 2n minus 1 factorial. This is the another form, another summation notation for sin z for modulus of z is less than infinity is here also for modulus of z less than infinity. Direct question adugutunnadandi sin z cos z x expansion adugutunnadu. For any complex number z sin z is equal to, for any complex number z cos z is equal to. Idana oka notation. Okay. Now similarly we can write the expansion of cos z. First I am taking f of z is equal to cos z for modulus of z less than 1. Then modulus of z less than infinity. Then f of z, cos z is an even function. That's why we can write f of z is equal to first term 1 minus z square by 2 factorial plus z cube by, sorry, z power 4 by 4 factorial plus sorry, is minus z power 6 by 6 factorial plus and so. Okay, all the odd terms we are, even terms we are taking. So here it is 4 factorial. So cos z can be written as cos z is equal to, in summation notation, summation n is equal to 0 to infinity minus 1 to the power of n into z power 2n divided by 2n factorial. Z power 2n divided by 2n factorial for modulus of z less than infinity. For mod z less than infinity. Okay. Similarly, we can write another form for the expansion of cos z. This cos z is equal to summation n is equal to 1 to infinity. N is equal to 1 to infinity minus 1 to the power of n minus 1 into z power 2n minus 2 even terms. Okay, divided by 2n minus 2 factor for modulus of z less than infinity. For modulus z less than infinity. This is the another expansion of cos z. Okay, primary ga మనం ఈ గుర్తు పెట్టుకోవాలండి. Next log z, log 1 plus z expansions కూడా తర్వాత డిస్కస్ చేద్దాం. Okay. Now first ఇక్కడ మన క్వశ్చన్ ఎలా అడుగుతాడంటే ఎక్స్పాండ్ ది ఫంక్షన్ యాజ్ పర్ లారెన్స్ సిరీస్ ఆర్ టేలర్ సిరీస్ అని అడుగుతాడు. లారెన్స్ సిరీస్ కూడా మనం ఒకసారి డిస్కస్ చేద్దాం. ఇఫ్ యు ఆర్ టేకింగ్ f of z, the analytic function in an annulus in sin hz and cos hz అంటున్నారు. ఓకే, ఇక్కడ ఏం లేదండి, sin hz cos hz లలో సింపుల్ గా యూ హ్యావ్ టు రిమెంబర్ ఫ్రమ్ దిస్ వీ కెన్ రైట్ sin hz అంటే ఇలా రాసుకోవచ్చు, hyperbolic function, just summation n is equal to 0 to infinity z power 2n plus 1 divided by 2n plus 1 factorial. There is no negative terms, all positive terms ఏ వస్తాయండి. అంటే ఇక్కడ ఏమొస్తుంది అప్పుడు ఫస్ట్ టర్మ్ z, ఫస్ట్ టర్మ్ n equal to 0, z by 0 factorial is 1 factorial is 1. Next term z cube by 3 factorial. Next term z power 5 by 5 factorial plus and so on. These are the expand. This is the expansion of sin hz. Similarly, for cos hz, నేను యూజ్ చేసుకుంటున్నాను cos hz. Just remove the alternative plus and minus. That means summation n equal to 0 to infinity minus 1 to the power of n remove చేయండి. remove cheste z power 2n divided by 2n factorial. Okay, 2n factorial అంటే ఎక్స్పాన్షన్ చేస్తే సరిపోతుంది. దీన్ని అంటే మీరు గుర్తుపెట్టుకోవాల్సింది ఏంటంటే జస్ట్ పాజిటివ్ టర్మ్స్ ఏ ఉంటాయి. అంటే z ఫస్ట్ టర్మ్ and we take n is equal to 0, 1, second term z square by 2 factorial, third term z power 4 by 4 factorial plus and so on. Okay, ఇలా ఓన్లీ పాజిటివ్ టర్మ్స్ ఏ ఉంటాయి. అదే ట్రిగ్నోమెట్రీ ఫంక్షన్ లో అయితే పాజిటివ్ నెగటివ్ టర్మ్స్ వస్తాయి. ఇందులో మాత్రం ఓన్లీ పాజిటివ్ టర్మ్స్ ఏ ఉంటాయి. ఇలా గుర్తుపెట్టుకోండి. ఓకే, గుడ్ క్వశ్చన్. నౌ we are taking f of z is analytic function in an annulus. Annulus means the region bounded by two concentric circles. For example, if we take a circle Z0 center, if we consider another circle with a different radius, okay, this region, the area bounded by these two. Okay, first circle యొక్క radius R1 అని తీసుకుంటున్నా, second circle యొక్క radius R2 తీసుకుంటున్నా. So R1 is less than modulus of Z minus Z0 is less than R2. This is called annulus region. Z square by 2 factorial second term Z power 4 by 4 factorial plus and so on. Okay, annulus region ante the region bounded by two concentric circles. That means R1 is less than modulus of Z minus Z0 is less than R2. In an annulus, R1 is less than modulus of Z minus Z0 is less than R2. Okay, then f of z can be represented as, when f of z is equal to summation n is equal to 0 to infinity an into Z minus Z0 equal to the power of n plus summation n is equal to 1 to infinity bn divided by Z minus Z0 whole to the power of Z minus Z0 whole to the power of n. Okay, here this part is called analytic part. This is analytic part, and this part here the function is not analytic at z equal to z1, so that it is called principal part. Okay, the principal part దగ్గర function analytic or function not defined. Okay, function defined అయిందనుకోండి, that we have the expansion of f of z must be Taylor series expansion. Function define కానప్పుడు, okay, ఆ ఫంక్షన్ ను స్మూత్ చేయడానికి మనకు లారెన్స్ సిరీస్ ఎక్స్పాన్షన్ యూజ్ చేస్తాం. Okay, is called, then f of z is equal to this is called, which is the Lorentz series, which is Lorentz series expansion. Okay, ఇక్కడ మనకు క్వశ్చన్ ఎలా వస్తాడంటే అడుగుతాడంటే expand the function in Lorentz series about z equal to z0, or expand the function about in Taylor series when z equal to some values. Okay, first I'm taking one example, simple example తీసుకుంటాను. First I am consider Taylor series expansion ఎలా ఉంటుంది, Lorentz series expansion ఎలా ఉంటుందో చూద్దాం. ఫస్ట్ let f of z is equal to 1 by z about the point z equal to 0. Okay, z0 is 0. Clearly we can observe the function is not analytic at z equal to 0. It is a singular point. Okay, so for this function we have to expand as per Taylor series. Okay, ఎలా expand చేస్తాం, then Taylor's series expansion. Taylor series expansion for modulus of z less than 1. For modulus of z less than 1 condition this could. So we can write f of z is equal to z power minus by z. I'm sorry, I'm taking not this one. Sure, you can consider it z is equal to 2. Okay, then Taylor series expansion for this function. Okay. Is your, we'll discuss later. About the point z equal to 2. For this, we have to take f of z is equal to 1 by z. That is equal to, we can write z minus 2 plus 2. Okay. We have to construct the circle. Actually, circle entry mod z is equal to 2 means we have to construct the circle modulus of z minus 2 is less than 1. So we have to convert the function in terms of z minus 2. Z minus 2 loki convert square. So this is equal to 1 by 2 of z minus 2 divided by 2 plus 1. We are taking 2 as common here. Okay. So this is equal to 1 by 2 of, take to numerator here, z minus 2 divided by 2 whole to the power of minus 1. To the power of minus 1. So it is in the form of 1 plus x whole to the power of minus 1 form. So that is equal to 1 minus x, 1 minus z minus 2, a complete term here, z minus 2 by 2 plus z minus 2 by 2 whole square, alternative plus and minus, here minus z minus 2 by 2 whole cube plus x. This is the expansion. So this is equal to 1 by 2 of first term 1 minus 1 by 2 of z minus 2, second term 1 by 2 whole square into z minus 2 whole square, and 1 by 2 whole cube z minus 2 whole cube plus x. So this is equal to, if you can multiply with 1 by 2 here. So here I am sorry, 1 by 2 whole cube, here z minus 2 whole cube, last term, sorry, third term. And you can multiply with 2, 1 by 2. So we get 1 by 2 first term, 1 by 2 whole square into z minus 2, and plus 1 by 2 whole cube into z minus 2 whole square, and minus 1 by 2 whole to the power of 4 into z minus 2 whole to the power of 4 plus and so on. This is the Taylor series expansion about this is which is Taylor series expansion. Taylor's series expansion. Expansion about z equal to 2. Okay. The modulus of z minus 2, this term completely here modulus of the condition is old. Actually, the expansion of 1 plus x whole to the power of minus 1 is 1 minus x plus x square minus x cube plus and so on. For modulus of x less than 1, this is the condition. So here the condition is here we are taking x as z minus 2 by 2. So the condition is modulus of z minus modulus of z minus 2 divided by 2 is less than 1. So here modulus of z minus 2 divided by 2 less than 1. That is nothing but modulus of z minus 2 is less than 2. Okay. The expansion of f of z is equal to 1 by z about the point z equal to 2 is valid for modulus of z minus 2 is less than 2. Okay. Ikkada valid. The region of convergence is modulus of z minus 2 is less than 2. This Taylor series expansion. Next, this function ku manam Lorentz series expansion. The condition emotundante reverse avutundi. Modulus of z minus 2 divided by 2 is greater than 1. Actually, modulus of z minus 2 is less than 2 ante inside or interior the circle. Modulus of z minus 2 greater than 1 ante outside of the circle. Outside of the circle. Okay. ఎలా చేస్తామంటే ఫంక్షన్ ఇక్కడ గుర్తుపెట్టుకోండి, ఫంక్షన్ అనేది z minus 2 డినామినేటర్ లో వచ్చేటట్టుగా మనం ఎక్స్పాండ్ చేయాలి. ఫర్ ఎగ్జాంపుల్ we take f of z function. I'm taking one function here. F of z is equal to 1 by let f of z is equal to 1 by 1 minus z. 1 by 1 minus z about the point z equal to 1. About the point z is equal to 1. Okay. Z equal to 1 means you have to observe here. There is two possibilities are there. For modulus of z less than 1 and for modulus of z greater than 1. Okay. Modulus of z less than 1 means interior to the circle. Circle ante ela untundi. In radius 1 unit ante. Modulus of z less than 1 interior ante. Modulus of z greater than 1 ante outside, exterior of the circle. You know, exterior no. The modulus of z greater than 1. Okay. Now, first we can write f of z is equal to 1 by 1 minus z as 1 minus z whole to the power of minus 1 by the expansion of 1 minus x. The original expansion is 1 plus x square plus x cube plus and so on. This is valid for modulus of x less than 1. So this is the expansion of 1 minus x whole to the power of minus 1. So here 1 plus z square plus z cube plus and so for modulus of z less than 1. Okay, this is the expansion, and this expansion is called Taylor series. Taylor's series expansion. Now for this function, we have one more choice is there, that is modulus of z greater than 1. So for modulus of z greater than 1, we can write it as we are taking the reciprocal here. 1 by mod z is less than 1. When we take the reciprocal, it will become inequality become changes. So from this we can write 1 is less than modulus of z. Okay, అంటే ఇక్కడ ఇలా కాకుండా నేను రాస్తాను 1 by z modulus అండి, దానికి modulus of z. అంటే ఇప్పుడు గుర్తుపెట్టుకోవాల్సింది ఏంటంటే mod z less than 1 అయినప్పుడు ఫంక్షన్ యొక్క ఎక్స్పాన్షన్ ఓన్లీ జెడ్లలో ఉండాలి. ఈ మాడ్యులస్ లో ఏ టర్మ్ అయితే ఉందో దాంట్లోనే ఉండాలి. ఇప్పుడు ప్రీవియస్ ప్రాబ్లం లో కూడా మాడ్యులస్ ఆఫ్ z-2 లెస్ దెన్ సమ్ వాల్యూ ఇక్కడ 2 వచ్చాయి. కాబట్టి ఎక్స్పాన్షన్ కూడా ఇందులో ఉంది కంప్లీట్ గా z-2, లేదంటే z-2/2 ఎక్స్పాన్షన్ కూడా z-2/2 ఫామ్ లోనే ఉంది. ఓకేనా? కాబట్టి ఇక్కడ mod z లెస్ దెన్ 1 దగ్గర z లో ఎక్స్పాన్షన్ ఉండాలి. మాడ్యులస్ ఆఫ్ 1/z less than 1 condition దగ్గర expansion should be in terms of 1/z. So we have to write the function now. F of z is equal to 1/1 minus z as we can write, we can take 1 by, I'm taking minus z as common here. So 1/minus z plus 1 ఈ ఫామ్ లోకి వచ్చేసి. So we can write it as minus 1/z of 1 minus 1/z whole to the power of minus 1. So this is equal to minus 1/z 1 plus same expansion 1/z plus 1/z whole square plus 1/z whole cube plus and so. Okay. So multiply with minus 1/z. So we get minus 1/z first term, minus 1/z whole square minus 1/z whole cube minus 1/z whole to the power of 4 minus and so. Okay. And this expansion is called Lorentz series expansion. Lorentz series expansion. Okay. The difference ఏంటంటే లారెన్స్ సిరీస్ లో నెగటివ్ టర్మ్స్ ఉంటాయండి. z⁻−1, z⁻−2, z⁻−3. అదే టేలర్ సిరీస్ లో ఏమో పాజిటివ్ టర్మ్స్ మాత్రమే ఉంటాయి. 1 + z + z² + z³ అండ్ సో ఆన్. ఇలా మనం ఎక్స్పాన్షన్ చేసేటప్పుడు జాగ్రత్తగా చేసుకోవాలి. లారెన్స్ సిరీస్ లో అడుగుతున్నాడా, టేలర్ సిరీస్ లో అడుగుతున్నాడా చూసుకొని ఎక్స్పాన్షన్ చేసుకోవాలి. ద కాన్సెప్ట్ బిహైండ్ Taylor series and Lorentz series. Okay. Now I'm taking one problem, a simple problem. First I'm taking a simple problem from set. Of course, deal good at in the Lorentz series expansion. In the Lorentz series expansion of f of z is equal to z-3 into sin 1/z + 2. 1/z + 2 about z = -2. About z = -2. The coefficients of detail question. The coefficients of z + 2 whole to the power of -2 and z + 2 whole to the power of -1 are respectively. First we have to calculate z + 2 whole to the power of -2 coefficient, then z + 2 whole to the power of -1. We have options here. First option 1/6 -5. Second option -1/6, 5. Third option 1/6, 5. And the fourth option -1/6, minus 5. These are the 4 options we have. First, we have to expand the function f of z in terms of Filani series. The function f of z is z minus 3 into sine of 1 by z plus 2. Clearly, we can observe z equal to minus 2 is singular point. Okay. So we have to convert the series in terms of z plus 2. Okay, z is equal to minus 2 and more or less z plus 2 is equal to 0. Z plus 2 loki convert cheskovali. So, but we are given here z minus 3. So we can write z minus 3 as z plus 2 minus 5 into sine 1 by z plus 2. Okay. So we can write it as z plus 2 into sine 1 by z plus 2. We are multiplying, just sine to multiply just minus 5 into sine of 1 by z plus 2. Okay, simple. Now expand according to sine function. Okay, there is z equal to 1 by z plus 2. Z minus z cube by 3 factorial plus z power 5 by 5 factorial minus z power 7 by 7 factorial, like that. So 1 by z plus 2 z minus z cube 1 by z plus 2 whole cube by 3 factorial. Okay, like z plus 2 whole to the power of minus 2 ante ikkada vachestada saripodi rendu terms chalu plus and so. Okay, next term minus 5 into same 1 by z plus 2 second term minus 1 by z plus 2 whole cube by 3 factorial plus and so. Now we can multiply here with the z plus 2. First term is 1. Here the second term 1 by 6 into z plus 2 whole to the power of ikkada cube denominator lo untundandi, numerator lo 1 undi kabatti power minus 2 plus and so on. This is first term minus 5 into here z plus 2 whole to the power of minus 1. Here 1 by 6 into z plus 2 whole to the power of minus 3 plus signs. Okay, ఇక్కడ చూడండి అన్ని టర్మ్స్ లలో నెగటివ్ టర్మ్స్ ఏమున్నాయి చూడండి, నెగటివ్ పవర్స్ ఏమున్నాయి. ఎందుకు నెగటివ్ పవర్స్ ఉన్నాయంటే ఇట్ ఈస్ ఏ Lorentz series expansion. That's why. Okay, but we have to calculate the coefficient of, therefore coefficient of z plus 2 whole to the power of minus 2, that is equal to minus 1 by 6. ఇక్కడ ఒక దగ్గరే వస్తుంది, మళ్ళీ ఇక్కడ ఎక్కడ రాదు. z plus 2 whole to the power of minus 2 coefficient రాదు. Next coefficient of z plus 2 whole to the power of minus 1. This coefficient, for this coefficient is minus 5. Minus 1 by 6 minus 5. So yeah, fourth option is the right option. Like this we can do the problems. Okay. Now I am taking another problem. From Lorentz series. After that we'll discuss number of zeros. Next I am taking a Taylor series expansion of, it is also set question, the Taylor's series expansion of f of z is equal to z minus 1 divided by z plus 1 about the point z is equal to 1 is. Okay. కొంచెం ఆప్షన్స్ పెద్దగా ఉంటాయండి. నేను ఇది ఒకదానికి ఆప్షన్స్ రాస్తాను, మిగతా వాటికి రాయండి. ఓకే, చూపించడం కోసం రాస్తాను. ఫస్ట్ ఆప్షన్ ఏంటంటే 1/2 z minus 1 minus 1/2 whole square into z minus 1 whole square plus 1/2 whole cube into z minus 1 whole cube minus. Second option 1/2 z minus 1 plus 1/2 whole square into z minus 1 whole square plus 1/2 whole cube into z minus 1 whole cube plus answer. And the third option z minus 1 into 1/2 into z minus 1 whole square plus 1/2 whole square into z minus 1 whole cube minus and so on. And the fourth option will be z minus 1 into z minus 1 plus 1/2 into z minus 1 whole square 1/2 whole cube into z minus 1 whole cube whole square into z minus 1 whole cube plus. Okay, every time we'll options radam ante koncham so what we can do the problem directly. First we have to observe, we have to expand the function about the point z equal to 1 means we have to convert the function in terms of z minus 1. We have to convert the function in terms of z minus. So first of all, I am taking the function f of z is equal to z minus 1 divided by z plus 1. So we can write it as z minus 1 divided by z minus 1 divided by z minus 1 plus 2. Okay, we can take 2 common in the denominator, so numerator becomes same 2 into 1 plus z minus 1/2. Okay, and we can write 1/2 into z minus 1 plus z minus 1/2 whole to the power of minus 1. This is the expansion. Okay, so it is in the form of 1 plus x whole to the power of minus 1. So that formula is 1 minus x plus x square minus x cube plus and so on for mod x is less than 1. So you can write it as 1/2 of okay. Yeah. Here, actually, the function is z minus 1 by z plus 1. So we can write z minus 1 by z minus 1 plus 2. We can take 2 common in the denominator. Z minus 1 numerator as this 2 times of z minus 1/2 plus 1. Okay, so 1/2 times of technical problem. Here we can write 1/2 as this, z minus 1 also as this, and take the term into numerator, that become 1 plus z minus 1/2 whole to the power of minus 1. We can expand by using 1 plus x whole to the power of minus 1 expansion. 1 by 2 z minus 1 as this. Here 1 minus z minus 1 divided by 2. First term z minus 1 whole square by 2 square. Actually z minus 1 by 2 whole square minus z minus 1 whole cube by 2 cube plus times. Okay, this is the expansion. And multiply with 1 by 2 z minus 1. First term is 1 by 2 into z minus 1. Second term 1 by 2 whole square into z minus 1 whole square. Third term 1 by 2 whole square 1 by 2 whole cube out. Sorry. Yeah, 1 by 2 whole cube into z minus 1 whole cube minus and so on. Next term into 1 by 2 whole to the power of 4 into z minus 1 whole to the power of 4. This term is okay. 1 by 2 z minus 1 minus 1 by 2 z minus 1 whole square. So first option is the right option. Okay. First option. Therefore, option 1 is correct. Now I'm taking another problem. It is also from SET. It is a NARASIMHA series. The Lorentz series expansion is set. The Lorentz series expansion of f of z is equal to z square minus 1 divided by z square plus 5z plus 6 we do next we discuss. Yes. I'm taking another problem. After that, we'll discuss this question. It is from JL question. If log z is equal to, is a JL question. If log z is equal to summation n is equal to 1 to infinity Cn z minus 1 whole to the power of n, then Cn is equal to, we have options here. First option 1 by n, second option minus 1 by n, third option minus 1 to the power of n by n, and the fourth option minus 1 to the power of n minus 1 by n. Okay. So we are given log z is equal to summation n is equal to 1 to infinity Cn z minus 1 whole to the power of n. Okay. So actually Cn, the expansion of log z is, we have log z expansion about z equal to 1 is, first term is 1 by 1 into z minus 1. That is 1 into z minus 1. Second term, when we take, directly raskunte ayipotundi. That is the expansion of log z is z minus 1 minus z minus 1 whole square by 2 plus z minus 1 whole cube by 3 minus z minus whole to the power of 4 by 4 plus and so. This is expansion. So we can write log z is equal to, it is z minus whole to the power of n and summation n is equal to 1 to infinity. Here alternatively plus and minus. First term is plus and plus ante n equal to 1 నుండి స్టార్ట్ చేస్తున్నాడు కాబట్టి -1 to the power of n minus 1 రాయండి. 0 నుండి స్టార్ట్ చేశాడు అనుకోండి -1 to the power of n తీసుకోవచ్చు. డివైడెడ్ బై ఇయర్ 1, ఇయర్ 2, ఇయర్ 3, ఇయర్ 4. కాబట్టి ఇక్కడ ఏమొస్తుంది బై n. సో దిస్ ఈజ్ నథింగ్ బట్ సమ్మేషన్ n is equal to 1 to infinity -1 to the power of n minus 1 by n into z minus 1 whole to the power of n. Okay. So therefore Cn is equal to -1 to the power of n minus 1 divided by n. This is the coefficient. Okay. Now we are given another problem in the same JL question paper.
Sir, excuse me, sir.
Yes.
Log Z, how to write that expansion?
By using Maclaurin's series. About z is equal to 1. About z is equal to 1, we can expand by using Maclaurin's series. Okay. Like this, మనం ఇక్కడ e to the power of z and cos z sin z expansion ఎలా అయితే యూజ్ చేసామో అలానే ఎక్స్పాండ్ చేయొచ్చు అండి. ఓకే. Now I am taking another problem. The expansion of log 1 plus z. Okay. Same question paper, real question, JL question paper. If the condition modulus of z less than 1, then summation n is equal to 1 to infinity -1 to the power of n plus 1 into z power n by n. Summate if mod whole to the power of -1. Second option, log 1 plus z. Third option, minus log 1 plus z. And fourth option, log z. These are the options we have. Now, first we know that we have to write the expansion. We have to remember the expansion of log z expansion. ఇక్కడ రాసుకున్నామండి log z expansion. Similarly, we can write the expansion of log 1 plus z. Log 1 plus z. Log 1 plus z is equal to the expansion is z minus z square by 2 plus z cube by 3 minus and so on. This is the expansion of log 1 plus z. So we can write log 1 plus z in terms of summation, that is n is equal to 1 to infinity. Here the terms are we are given మనకి ఎలా ఇచ్చాడు -1 to the power of n+1 అని రాసాను అనుకోండి. ఫస్ట్ టర్మ్ ఏమవుతుంది, పాజిటివ్ టర్మ్ అవుతుంది. z పవర్ n by n అంతే కదా. సో డైరెక్ట్ ఇది సో సెకండ్ ఆప్షన్ ఇస్ ద నెక్స్ట్. in the same JL question we have another question paper. We have another question. If modulus of z greater than 2, then summation n is equal to 0 to infinity 2 power n divided by z power n+1 is equal to. We have options. First option 1 by z minus 2. Second option 1 by z plus 2. Third option 1 by 2 minus z. And fourth option 1 by z plus 2. Z by z plus 2. Z, this is z, this is plus 2. Okay. ఇక్కడ మనం డైరెక్ట్ దీన్ని ఎక్స్పాండ్ చేయడం కంటే ఆప్షన్ చెక్ చేసుకుందాం. మనం 1 by 1 ఆప్షన్ చెక్ చేసుకుందాం. ఓకే, ఫస్ట్ ఐఎమ్ టేకింగ్ దిస్ ఆప్షన్ 1 by z minus 2. But we are given the condition. You have to observe. First I'm taking the condition. That is modulus of z greater than 2. When modulus of greater than 2, then the when we take the reciprocal, this is less than 1 by 2. So we can write 2 by mod z is less than 1. That implies 2 by z, modulus of 2 by z less than 1. This is the actual original condition. Okay. So we go from options. Sorry. First option 1 by z minus 2. Second option 1 by z plus 2. Okay. 1 by 1 check చేస్తాను options. Option 1. Okay, we'll discuss. First option check చేస్తాను. First option check చేయాలని ఏం లేదు, ఇష్టం, as your wish. First I am checking the option 1. Okay. That is 1 by z minus 2. We have to convert the function in terms of 2 by z. 2 by z లోకి కన్వర్ట్ చేసుకోవాలి. అంటే 1 by z కామన్ తీసుకోండి. Z కామన్ తీస్తే 1 minus 2 by z. So this is equal to 1 by z of 1 minus 2 by z whole to the power of minus 1. So now expand this 1 by z of, by using 1 minus x whole to the power of minus 1 expansion. Okay. So 1 plus 2 by z, second term 2 by z whole square plus and so on. Okay. So we can write it as 1 by z first term, 1 by z కదా. Okay. 2 by z square, second term 2 square by z cube plus and so. So this can be written as in summation notation. Summation n is equal to 0 to infinity. Here 2 power 0, 2 power 1, 2 power 2. That is 2 power n. Denominator 0 plus 1, 0 plus 2. That is z power n plus 1. 0 plus 1, 0 plus 2. n equal to ఇలా రాసుకోవచ్చు. n plus 1. Okay, సరిపోతుంది కదా. n equal to 0. z power 1 n equal to 2 z square n equal to 1 z square n equal to 2 z cube and so this is expansion. So option 1 is the right option. Okay. So first option. Okay. మన ప్రతిసారి ప్రాబ్లం నుండి రావడం కంటే ఇలా కూడా మనకి ఈజీగా ఉంటే అవుతుంది. లేదంటే ప్రాబ్లం దాన్ని ఎక్స్పాండ్ చేసినా కానీ ఇలానే వచ్చేస్తుంది. దాన్ని ఎక్స్పాండ్ చేయాలి, మళ్ళీ దీన్ని ఎక్స్పాండ్ చేయాలి, రెండు కంపారిజన్ చేసుకుంటే సరిపోతుంది. Okay. I am taking another problem. From jail, it is also from jail. Another question paper. The Lorentz series expansion. Sorry, it is DL. I'm sorry. The Lorentz series of z minus 1 divided. This is z. Z by, I think, z minus 1 into z minus 3 for modulus of z minus 1 less than 2. Modulus of z minus the numerator no certainly determined. Okay, let me see. First, I'm taking the function f of z is z divided by z minus 1 into z minus 3. For the condition is z minus 1 is less than 2. So we have to convert the function in terms of z minus 1 just. Okay. So this is equal to, we can write z minus 1 plus 1 numerator, denominator. First దీన్ని split చేద్దామండి మనం. అంటే by using partial fractions ప్రకారం split చేద్దాం. Okay. First I am writing z minus 1 here and write z equal to 1. While writing 1, we get 1 minus 2 1 minus 3 plus I am writing here z minus 3 and substitute z equal to 3. We get 3 minus 1. The numerator is 3. Okay. So here 1 by 1 minus 3 minus 2 into z minus 1. Here 3 by 2 into z minus 3. Okay. So we can write it as minus 1 by 2, 1 by minus 2 into z minus. Okay, here we can write minus 1 by 2 into z minus 1, minus 1 by 2 into z minus 1. There is no problem here. Okay, plus here we can write 3 by 2 into, here we don't have z minus 1 term. We can converge z minus 1 minus 2. So this is equal to minus 1 by 2 in, we can write this is as this, minus 1 by 2 into 1 by 2 into z minus. Okay. Here we can take a minus 2 common here. When we take minus 2 common, z minus 1 by minus 2 plus 1. Z minus 1 by minus 2 plus 1. So this is equal to minus 1 by 2 into z minus 1 minus 3 by 4. 3 by 4. ఈ టర్మ్ లో న్యూమరేటర్ తీసుకెళ్తున్నా 1 ఇక్కడ మైనస్ వస్తుంది. z minus 1 divided by 2 అండి, whole to the power of minus. ఇక్కడ మన కండిషన్ ఏంటంటే ఏమి ఇచ్చాడంటే వాడు modulus of condition is modulus of z minus 1 is less than 2 అని ఇచ్చాడు. అంటే modulus of z minus 1 by 2 less than 1 అవుతుంది. That means modulus of z minus 1 divided by 2 is less than 1. Okay, this is the actual condition. So mod x is less than 1 form లో ఉంది. కాబట్టి we can use the expansion of 1 minus x whole to the power of plus 1. So this is equal to minus 1 by 2 into z minus 1 minus 3 by 4 of, here the expansion 1 plus z minus 1 by 2 first term, second term z minus 1 by 2 whole square plus the third term z minus 1 by 2 whole cube plus and so on. Okay, so this is equal to minus 1 by 2 into z minus 1 minus 3 into, we are taking 2 inside. This can be written as 1 by 4, 1 by 4 of first order. Here z minus 1 by 2 into 4. Here z minus 1 whole square by 2 in 4 into 4. Next term z minus 1 whole cube by 8 into 4 plus and so. This is the term. So here there is no change in the first term. 1 by z minus 1 minus 3 into, we can write here 1 by 2 square plus z minus 1 by 2 cube plus z minus 1 whole square by 2 power 4. Next z minus 1 whole cube by 2 power 2, 2 power 3, 2 power 5 plus and so. Okay, so we can write in the summation notation. Summation notation is minus 1 by 2 into z minus 1 minus 3 into summation n is equal to 0 నుండి స్టార్ట్ చేసుకో, 1 నుండి స్టార్ట్, ఎందుకంటే ఆప్షన్ నేను ఇస్తాను ఆప్షన్స్. 1 is 1. Here 3 summation n is equal to 1 to infinity. Here z minus 1 whole to the power of n minus 1. When we take n is equal to 1, we get a power 0 is 1. Okay, denominator is 2 power n plus 1. 2 power n plus 1 సరిపోతుందా? n equal to n plus 1. So this is the expansion of Lorentz series of the function. Okay, you can see the previous question paper చూస్తే ఇది ఉంటుంది. Okay, we can expand like this. Now I am taking options చాలా పెద్దగా ఉన్నాయి కాబట్టి నేను ఆప్షన్స్ తీసుకోవట్లేదండి. When we take n is equal to 1, it is balanced, n equal to 2, okay, n equal to, so I am taking 2 power n plus 1, okay, it is okay.
Sir, denominator రావాలి z minus 1.
ఏంటండి?
z minus 1 denominator రావాలి కదా సార్. 1 by z minus 1, 1 minus z minus 1 whole square. Lorentz series.
ఇదేనండి, ఇక్కడ మన కండిషన్ ఏంటి? z minus 1 is less than 2 కాబట్టి this is less than 1 అవుతుంది. అప్పుడు modulus of z.
సార్ అనాలిటిక్ పార్ట్ ఉంది, మనకి ప్రిన్సిపల్ పార్ట్ ఉంది. ప్రిన్సిపల్స్ పార్ట్ -1/2 into z minus 1.
ఇది ఉంది ఇక్కడ, ఇది ఉంది అంటే ఇక్కడ ఉంది నెగటివ్ పార్ట్ ఉంది కదా, ఇక్కడ ఉంది. ఇదేమో అనలిటిక్ పార్ట్ అండి. లారెన్స్ సిరీస్ లో అనలిటిక్ ఉంటుంది అండ్ ప్రిన్సిపల్ పార్ట్ ఇదండి. ఓకే -1/2 ఇంటూ z-1 ఇది వోల్ట్ పై తీసుకెళ్ళామనుకోండి ఇది పవర్ -1 అవుతుంది. ఓకేనా, ఇది నెగిటివ్ పార్ట్, ఇదేమో అనలిటికల్. ఓకేనా,
ఓకే
టూ పార్ట్స్ ఉంటాయి. ఓకే, టేలర్ సిరీస్ ఉంటుంది యాజ్ వెల్ యాజ్ మెక్లారెన్ సిరీస్ అంటే లారెంట్ సిరీస్. రెండు మనకు రెండు ఎగ్జిస్ట్ అవుతాయి. ఓకేనా, కాబట్టి నెగిటివ్ టర్మ్స్ కంపల్సరీ, లారెంట్ సిరీస్ అంటే నెగిటివ్ టర్మ్స్ కంపల్సరీ ఉండాల్సిందే. ఇక్కడ నెగిటివ్ టర్మ్ ఏంటంటే -1/2 z-1 అనేది నెగిటివ్ టర్మ్. ఓకే, పైకి తీసుకెళ్ళామనుకోండి, న్యూమరేటర్ తీసుకెళ్ళామనుకోండి z-1 హోల్ టు ది పవర్ ఆఫ్ -1 అవుతుంది. ఓకే,
దీన్ని రెసిడ్యూ కనుకోవచ్చు కదా సార్, మా 1 దగ్గర -1/2
జస్ట్ రెసిడ్యూ అంటే డైరెక్ట్ ఏమొస్తుంది -1/2 వస్తుంది అంతే. రెసిడ్యూ ఎట్ z = 1 ఈస్ -1/2. ఓకేనా, now I am taking another problem from set. The series summation n is equal to 2 to infinity -1 to the power of n z power 2n by 2n factorial for mod z less than infinity represents. We have options here. First option sin z minus z. Second option tan z. Third option sec z minus z cube by 3 factorial. And the fourth option cos z minus 1 plus z square by 2. These are the four options. ఇక్కడ అబ్జర్వ్ చేయాల్సింది ఏంటంటే వీఆర్ గివెన్ ఈవెన్ టర్మ్స్ ఓన్లీ. జస్ట్ ఐఎమ్ ఎక్స్పాండింగ్ దిస్ టర్మ్. ఫస్ట్ టర్మ్ ఈజ్ z power 4 by 4 factorial. Next n equal to 3 z power 6 by 6 factorial. Next term z power 8 by 8 factorial plus and so on. Even terms అయితే sin z కాదు cos z కాదండి. ఇక్కడ there is no chance because sin z is odd function. మనకు ఈవెన్ ఫంక్షన్ ఏంటి secant z cos z. These two are even functions. Okay, ఈవెన్ ఫంక్షన్ లో secant z లో ఆడ్ టర్మ్ ఉంది కాబట్టి ఇది కూడా కాదని డైరెక్ట్ చెప్పవచ్చు. ఫోర్త్ ఆప్షన్ డైరెక్ట్ టిక్ పెట్టేయచ్చు, నో ప్రాబ్లం. ఓకే, ఇక్కడ ఏం చేశాడంటే దీన్ని ఏం చేస్తాను నేను 2 టర్మ్స్ యాడ్ చేస్తాను. one we can add one first term.
సార్ ఎక్స్పాన్షన్స్ లో నెగటివ్ టర్మ్స్ కూడా ఉంటాయి సార్.
ఇక్కడ నెగటివ్ టర్మ్ వస్తుంది. సారీ, it is negative, it is positive, it is negative. Yeah, here z power 4 by 4 factorial, z power 6 by 6 factorial plus and so అనుకుంటాను. ఇక్కడ ఏం చేశాను నేను 2 టర్మ్స్ యాడ్ చేశాను కాబట్టి సబ్ట్రాక్ట్ చేద్దాం. -1 plus z square by 2 factorial. We are adding 1 and subtracting, here subtracting, here adding, so balance. Okay, up to this is nothing but cos z. To this cos z, here -1. Okay, next term plus z square by 2 factorial. So fourth option is right option. Like this we can simplify. లేదంటే డైరెక్ట్ కూడా మీరు టిక్ పెట్టవచ్చు. ఓకేనా, now I'm taking another problem from set. I'm taking the principal part of the principal part of Lorentz series expansion of f of z is equal to z square plus 1 divided by sine z cube is. First option, 1 by z cube. Second option, 1 by z. Third option, 1 by z cube minus 1 by z. And fourth option, 1 by z cube plus 1 by z. So, principal part means non-analytic part. We have to construct. First, I am taking the function f of z is equal to z square plus 1 divided by sine z cube. Numerator is same, denominator is sine z అనుకోండి మొత్తం z cube ను z అని z cube minus z cube whole cube by 3 factorial plus z cube ఇంకో టర్మ్ అవసరం లేదు and so on. So this is equal to actually z square divided by these terms, z cube minus z power 9 by 3 factorial plus and so on. Just I am writing z square by z cube minus z power 3 factorial plus and so on, z power 9 by 3 factorial plus and so on. First term plus 1 by z cube minus z power 9 by 3 factorial plus and so on. So we can take z square common in the denominator. So z minus z power 7 by 3 factorial plus and so on plus 1 by z cube minus z power 9 by 3 factorial plus and so on. So here z square will be cancelled. Here we have 1 by z minus z square by z power 7 by 3 factorial plus and so on plus 1 by same z cube minus z power 9 by 3 factorial plus and so on. Okay. Now what is the principal part here? Z is 1 by z is the principal, 1 by z and 1 by z cube. Some of these two terms are the principal part, the expansion principal part. Okay. So 1 by z cube and 1 by z, 1 by z, 1 by z. Okay. 1 minute. is. I'm not writing the options here. Options రాసే టైంలో మనం ప్రాబ్లం చేయొచ్చు. Okay. Lorentz series expansion for condition is given for 1 less than modulus of z less than 3 is. It is 2 times. So first we have to see the condition. It is the annulus bounded by 2 concentric circles. That is, origin is the center, and first circle radius is 1 unit, and second circle radius is 3 units. Okay. So we have to expand the function in terms of z. In terms of z. First, I am writing the function f of z is equal to 1 by z minus 1 into z minus 3. Then f of z is equal to, we can take first I am splitting the partial fraction. By using partial fractions, we are splitting the fraction here. First I am writing z minus 1 term, and here z minus 3, and write z is equal to 1 here. So 1 minus 3, the numerator is 1, and here the numerator is 1, and substitute z equal to 3 here, that is 3 minus 1. Okay. So here minus 1 by 2 into z minus 1, here 1 by 2 into z minus 3. Okay. So this is equal to minus 1 by, we can take a minus common here in the denominator. 1 minus z, 1 minus z. Okay. Plus here I am taking minus 3 common. So minus 6 is minus 2. 1 minus z. Okay. So z. Okay. Here I am taking minus 3 common. So z by minus 3 plus 1. So this is equal to 1 by 2 of z minus 1 సరిపోతుంది కదా, no problem. 1 minus z. Okay. 1 minus z whole to the power of minus 1. Here minus 1 by 6, we can write 1 minus z by 3 whole to the power of minus 1. Okay. So this is equal to 1 by 2, expand this. 1 plus z plus z square plus and so on. First term. Second term, 1 by 6, 1 plus z by 3 plus z by 3 whole square. Z by 3 whole square plus and so. Okay. So this is equal to 1 by 2 into summation n is equal to 0 to infinity z power n at first term plus minus 1 by 6 summation n is equal to 0 to infinity z power n, we can write z by 3. Simply రాసుకోవచ్చు కదా, z by 3 whole to the power of n. Okay. This is the expansion. ఇక్కడ z by 3 లోకి ఎందుకు మార్చుకున్నాం, ఇక్కడ z లోకి మార్చుకున్నాం అంటే, ఫస్ట్ మనకి ఇచ్చిన కండిషన్ ఏంటి, 1 less than modulus of z less than 3 అండి, 1 less than mod z. So when we take a reciprocal, sorry, ఇక్కడ తప్పు చేసా. Okay, sorry. When we take the reciprocal, 1 greater than 1 by mod z అండి. So 1 by mod z is less than 1. కాబట్టి ఇక్కడ ఏమొస్తుంది, 1 by z మాడ్యులస్ టోటల్ మాడ్యులస్ ఈజ్ లెస్ దెన్ 1. ఇక్కడ కండిషన్ ఇలా తీసుకోవాలి మార్తం. అప్పుడు ఇక్కడ ఏమొస్తుందంటే కంప్లీట్ గా ఎడిట్ చేస్తున్నాను. ఇక్కడ కండిషన్ ఫస్ట్ కండిషన్ ఇదండి. కండిషన్ నుండే రావాలి, మనం ఎలా ఎక్స్పాండ్ చేయాలి. ఇది ఫస్ట్ కండిషన్. సెకండ్ కండిషన్ మాడ్యులస్ ఆఫ్ జెడ్ లెస్ దెన్ 3 కాబట్టి మాడ్యులస్ ఆఫ్ జెడ్ బై 3 లెస్ దెన్ 1 అవుతుంది. మాడ్ జెడ్ బై 3 లెస్ దెన్ 1 అంటే మనకు ఎక్స్పాన్షన్ ఏ ఫామ్ లో ఉండాలి, 1/z అండ్ z/3 ఈ ఫామ్ లో ఎక్స్పాన్షన్ ఉండాలి. ఓకే, సెకండ్ టర్మ్ ఓకే, ఫస్ట్ టర్మ్ మాత్రం మనకు 1/z లోకి రాలేదు. కాబట్టి ఇక్కడ ఏం చేయండి అంటే -1/2z, z కామన్ తీయండి, 1 - 1/z అవుతుంది. సెకండ్ టర్మ్ లో యాజ్ దిస్ గా -3 కామన్ తీయండి, 2 ఇలానే ఉంచండి. -3 ఇంటూ z/-3 ప్లస్ 1 ఇలా రాసుకో. ఓకే, అప్పుడు ఇక్కడ టర్మ్ ఏమవుతుంది, -1/2z 1/2z here 1 - 1/z 1 - 1/z whole to the power of -1 1 - z/3 is same. The term వచ్చేసి 1 plus here 1 minute. To infinity 1 divided z power n plus 1. We are taking z inside. So -1/6 into summation n is equal to 0. లేకుంటే నేను 3 ని లోపల తీసుకెళ్తాను. ఇక్కడ 2 రాయండి. ఓకే, ఒక 3 ని లోపల తీసుకెళ్తాను. అప్పుడు ఏమొస్తుంది, సమ్మేషన్ n is equal to 0 to infinity z power n by 3 power n 3 and 3 power n plus 1. Okay, this is the Lorentz series expansion. In this we can observe this is the principal part and this is the analytic. This is principal part and this is the analytic part. Okay, we have to careful about the కండిషన్. ఓకే, అన్యులేస్ ఏంటి, డొమైన్ ఏంటి, ఎలా ఇచ్చాడని దాని నుండి మనం తీసుకోవాలండి. ఇక్కడ డొమైన్ కండిషన్స్ పోయాయి, ఇక్కడ నేను మళ్ళీ నీట్గా రాస్తున్నాను. దిస్ ఈస్ ఫస్ట్ సర్కిల్ రేడియస్, దట్ ఈస్ r is equal to 1 and this is the second circle radius r is equal to 3. కండిషన్ ఏంటి, 1 less than modulus of z less than 3. So it is, you can write 1/z modulus is less than 1. Another condition is modulus of z less than 3. From this modulus of z by 3 less than 1, that is modulus of z by 3 less than 1. Okay, ఈ కండిషన్స్ నుండి మనం ఎక్స్పాన్షన్ అనేది చేసుకోవాలి. ఓకే, వెరీ ఈజీ అండి, బట్ ఇట్ ఈస్ చూడడానికి మనకు లెందీ కనిపిస్తాయి, దాన్ని మనం చాయిస్ కింద వేయకూడదు. Okay, now I am taking another problem from SET, is also from SET. The constant term in the Lorentz series, expansion of 1 minus sin z divided by z cube is constant term we have to find. Okay, first option -1/6, second option 1/6, third option 1, fourth option -1. Okay. Now we have to take the function f of z, that is equal to 1 minus sin z divided by z. So this is equal to 1 by z cube as this, and 1 minus expansion of sine z. Okay. So that is z minus z cube by 3 factorial plus z power 5 by 5 factorial minus and so. Okay. So we can write it as sin z lo 1 undadu. Okay, no problem. That is equal to 1 by z cube minus 1 by z square. Next 1 by first term 1 by z cube. Okay, 1 by z square, z cube cancel, minus of minus plus 1 by 3 factorial minus z square by 5 factorial plus and so alternative plus and minus. We have to find the constant term. Constant term is 1 by 3 factorial. Therefore, constant term is equal to 1 by 3 factorial, that is equal to 1 by 6. Okay. So what is our options? First option 1 minus 1 by 6, second option 1 by 6, and third option 1, fourth option minus 1. Okay. Now I'm taking another problem from set. Which of the following is the Taylor series? Which of the following is the Taylor series? Is the Taylor's series in problem with cheyalanడి of sin 2z of sin 2z in powers of z minus pi. Okay, z minus pi. First option 1 minus z minus pi whole square by 2 factorial plus z minus pi whole cube by 3 factorial minus and so on. Second option 2 into z minus pi plus 4 by 3 into z minus pi whole cube, plus and so on. And third option z minus pi plus 4 by 3 factorial into z minus pi whole cube plus and so on. And fourth option z minus pi whole square by 2 factorial plus 4 into z minus pi whole cube by 3 factorial plus and so on. Okay. These are the 4 options we have. Okay. You can do this problem.
Time it comes.
And pi minus z and cos pi minus z అంటే ఇక్కడ ఆల్రెడీ మైనస్ ఉంటుంది, మైనస్ మైనస్ ప్లస్ అవుతుంది. cos of minus theta is cos theta కాబట్టి cos pi minus z. ఓకే, దీన్ని ఎక్స్పాండ్ చేయండి, దీన్ని ఎక్స్పాండ్ చేయండి, మల్టిప్లై చేయండి. ఓకేనా, సైన్ ఆడ్ ఫంక్షన్, కాస్ ఈజ్ ఈవెన్ ఫంక్షన్. ఇప్పుడు 2 మల్టిపుల్ ఉంటుందండి అన్నిట్లో. 2 ఇంటూ సైన్ లో ఫస్ట్ టర్మ్ ఏంటి, పై మైనస్ జెడ్ టర్మ్ ఉంటుంది. కాస్ లో ఫస్ట్ టర్మ్ ఏంటి, 1 ఇంటూ పై మైనస్ జెడ్ అంటే పై మైనస్ జెడ్ వస్తుంది. అంటే సెకండ్ ఆప్షన్ ఇస్ ద రైట్ ఆప్షన్. ఓకే, ఐ థింక్ ఇదే లాజిక్ యూజ్ చేసి చేశాను. సో ఐఎమ్ రైటింగ్ జస్ట్ ఫస్ట్ టర్మ్ ఆఫ్ సైన్ పై మైనస్ జెడ్ and so on, and first term of cos pi minus z, that is 1 minus and so on. Okay, సో ఈ 2 టర్మ్స్ మల్టిప్లై చేస్తే 2 times of 5 minus z. రిమైనింగ్ టర్మ్స్ కూడా వస్తాయి. ఓకే, సో సెకండ్ ఆప్షన్ ఇస్ ద రైట్ ఆప్షన్. ఓకే, నౌ ఐఎమ్ టేకింగ్ another problem from set, is also from set. Actually, this is not related to Lorentz series and it is about zeros. The number of zeros, the number of zeros counting multiplicity of polynomial. Zeros counting multiplicities of polynomial. Z power 5 plus 3z cube plus z square plus 1. Inside the circle, modulus of z is equal to 2 is. This is a question. We have options here. First option 0, second option 2, third option 3, fourth option 5. First, we have to see the circle whose center at origin and radius is 2 units. Okay, this is 1, this is -1, -2, this is 1, this is 2. Okay, inside this circle we have to maximum number of zeros for this circle is 5. Okay, ఈ సర్కిల్ లో ది పాలినామియల్ కు 5 అండి. ఇందులో కూడా మనకి ఎన్ని ఛాన్సెస్ ఉంటాయి? 5 zeros ఉన్నాయి, ఛాన్సెస్ ఉన్నాయి. కానీ మన కండిషన్ చెక్ చేసుకోవాలి. we have to split the function into f of z and g of z. First I am taking function p of z is given function, that is z power 5 plus 3z cube plus z square plus 1. Okay, now I am consider f of z is equal to z power 5 and z power 5 and I'm taking like this, z power 5 plus 3z cube on this. G of z is equal to z square plus 1. Okay, then modulus of f of z is less than or equal to modulus of z power 5 plus 3 into modulus of z whole cube is equal to mod z is equal to 2 power 5 plus 3 into 2 power 3. This is 8 to 24, 32. That is 56. And the modulus of g of z is less than or equal to modulus of z whole square plus 1 and modulus of z1 plus z2 is less than or equal to mod z1 plus mod z2. I am using triangle inequality. So modulus of z is 2 square plus 1. This is equal to 5. Okay, so clearly we can observe modulus of f of z is always greater than modulus of g of z. Therefore, the number of zeros of f of z plus g of z, f of z plus g of z, nothing but p of z, is equal to the number of zeros of f of z. F of z zeros find out చేస్తే సరిపోతుంది. ఇన్సైడ్ c లోనే ఉండాలి. f of z zeros and f of z is equal to we are taken z power 5 plus 3 z cube. Then f of z has 5 zeros, has 5 zeros inside C. Okay, C లో 5 zeros ఉంటాయి కాబట్టి ఫంక్షన్ కూడా ఎన్ని జీరోస్ ఉంటాయి? therefore p of z is equal to f of z plus g of z as 5 zeros. 5 zeros inside C. సరే ఆ 5 zeros ఏంటో చూద్దాం. ఫస్ట్ f of z యొక్క 5 zeros చెక్ చేస్తాం. దట్ ఈస్ z power 5 plus 3z cube అండి. జీరోస్ అంటే ఈక్వల్ టు 0 కావాలి, ఇక్కడే తీసేసుకున్నాం. ఫర్ చెకింగ్ దిస్ ఇస్ 0, దట్ ఈస్ z power 5 plus 3z cube is equal to 0. Z cube as common, z square plus 3 is equal to 0. Z equal to 0 comma 0 comma 0 3 times, and here plus or minus root 3a. Okay, one plus root 3a, another one is minus root 3a, means 1.732 like this. Okay, 1.732 అంటే ఇన్సైడ్ ఉంటదండి కాబట్టి 5 zeros ఉంటాయి. ఓకే, ఆ 5 zeros ఇన్సైడ్ సి. ఆ జీరోస్ కంపల్సరీ ఇన్సైడ్ లో ఉండాలి, మనం చెక్ చేసుకోవాలి జీరోస్ ఉన్నాయి కాబట్టి ఆప్షన్ 4 is the right option. Okay, yes. Now I'm taking another problem from zeros. It is also from set. The number of zeros of the function okay, I will read the problem later. Okay, now I'm taking another problem. The Lorentz series expansion is from SET and TL question. SET and TL. Lorentz series expansion for f of z is equal to 1 by z square into 1 minus z for the region region 0 less than modulus of z less than 1 is. Okay, we have options here. First option, summation n is equal to 1 to infinity 1 by z power n plus 2. Second option, minus n is equal to summation n is equal to 1 to infinity 1 by z power n plus 2. Third option, summation n is equal to 1 to infinity 1 by z power n. And the fourth option, summation n is equal to 1 to infinity 1 by z power n minus 1. Okay, we have two conditions here. First, we have to check the condition. 0 less than modulus of z less than 1. Okay, option 1. Okay, we'll check. First, 0 less than 1, modulus of z. So 0 less than modulus of z. It is positive number and the condition is obviously 2 is less than 1. Okay. In this first region, in region okate untundi, modulus of z less than 1. So we can write the function f of z is equal to 1 by z square into 1 minus z as 1 by z square into 1 minus z whole to the power of minus 1. Let's expand this. So this is equal to 1 by z square. When mod z less than 1, this is the expansion. 1 plus z square. Okay. Mod z less than 1 kada. In the reciprocal this. Sorry. You can take a reciprocal here. 1 by mod z is greater than 1. Sorry. What will get? Z square into 1 minus. And put a denominator low name. Z square తీసుకోండి common. Z common తీయండి. Options. I'm taking minus z common here. So we get 1 by minus z plus 1 minus z cube అవుతుంది. Here 1 minus 1 by z whole to the power of minus 1. ఇక్కడ minus 1 by z cube అండి. టర్మ్స్ ఏంటి ఇక్కడ 1 plus 1 by z 1 by z whole square plus and so on. So this is nothing but minus 1 by z cube 1 plus 1 by z plus 1 by z square. Next term 1 by z cube plus and so on. No need to take the next term. Stop. No problem. Now I am writing minus of 1 by z cube plus 1 by z power 4, 1 by z power 5 plus and so on. Okay. So yeah, this is equal to minus summation. We can take n is equal to 0 to infinity. Taking and it low n equal to 1 to infinity with that. Yeah. Here also n is equal to 1 to here. So I'm taking n is equal to 1 to infinity. Here numerator is 1 for every term. The denominator is z power n plus 2 this one. N equal to 1 3, n equal to 2 4, n equal to 3 5. Okay, so this is the option, right option. So yeah. So minus n is equal to 1 to infinity 1 by z power n plus 2 is the option. Okay. Now I'm taking another term, another problem from DL. They simply Laurent series expansion of the function f of z is equal to taking 4z plus 3 divided by z into z minus 3 z plus 2 within mod z is equal to 1. Mod z is equal to 1. So mod z equal to 1 means I have to convert the function in terms of z power. I'm not taking the options here. So first I am writing the partial fractions here. First, writing the z value, z equal to 0 minus 3, 0 plus 2. Okay, numerator also 4 into 0 plus 3. Here, z minus 3 I am writing and replace z by 3 here. 3. This is 3 plus 2. Numerator also 3 plus 3. And next term, writing z plus 2 and replacing z by minus 2 remaining terms. Minus 2, minus 2, minus 3. The denominator numerator also minus 2 in place of z. So the function f of z is equal to here 3 divided by minus 3 into 2 into z plus 12, this is 15 divided by z minus 3 into 3 into 5 plus minus 8 plus 3, it is minus 5 divided by z plus 2 into minus 2 into minus 5. Here minus 5 will be cancelled. 5, 3 cancel, 3 cancel. So here we can write minus 1 by 2 z. Z expansion. Next plus we can take we can write 1 by z minus 3 అండి. z minus 3 నుండి మీరు minus 3 కామన్ తీసుకోండి. ఇప్పుడు z by minus 3 plus 1 ప్లస్ ఇక్కడ మైనస్ క్యాన్సిల్ అయిపోయింది, ఇక్కడ మైనస్ ఉంటుంది. మైనస్ 1 by 2 into 2 కామన్ తీసుకోండి. 2 కామన్ తీస్తే by 2 plus 1. So this is equal to minus 1 by 2z minus 1 by 3, 1 minus z by 3 whole to the power of minus 1 minus 1 by 4, 1 plus z by 2 whole to the power of minus 1. Actually, modulus of z is equal to 1 circle లో z by 2 ఉంటుంది, z by 3 కూడా. Okay. సో అంటే 1 by 3, 1 by 2 కూడా ఇన్సైడ్ అండి, సర్కిల్ కు ఇన్సైడ్ అవుతుంది. సో minus 1 by 2z minus 1 by 3, 1 plus z by 3 plus z by 3 whole square plus and so on. First term minus 1 by 4, 1 plus z by 2 plus z by 2 whole square plus and so on. Now use the summation notation. Minus 1 by 2z as this, minus 1 by 3 summation n is equal to 0 to infinity. Here we can write z by 3. ikkade raskochandi, no problem. ikkade kuda raskochu మీరు power n minus 1 by 4 summation n is equal to 0 to infinity z by 2 whole to the power of. Okay. This is equal to minus 1 by 2z minus summation n is equal to 0 to infinity z power n divided by 3 power n plus 1 minus summation n is equal to 0 to infinity z power n divided by 2 power here n plus 2. Okay. This is the expansion of
Sir, అక్కడ expansion 1 plus x whole to the power of minus 1.
yeah, I'm sorry. Where we have 1 minus here 1 plus
1/4 into sir. Minus 1/4 into దగ్గర.
okay, yeah. Here minus వస్తుంది. అంతే కదా? ప్లస్ here minus. కాబట్టి ఇక్కడ మనకి ఏంటి -1 to the power of n తీసుకుంటాం. కాబట్టి ఇక్కడ -1 to the power of n terms. Okay. Like this we can do problems. I'm taking one more problem. Almost all the problems of on Taylor series and Lorentz series we have covered some problems. I'm taking one problem.
Sir,
Yes, madam. You can ask.
నెంబర్ ఆఫ్ జీరోస్ మీద ఒకటి అవి కొన్ని ప్రాబ్లమ్స్ చెప్తా అన్నారు కదా సార్.
చెప్పాను నేను ఒక ప్రాబ్లం చెప్పాను, ఇంకొక ప్రాబ్లం నాకు ఇక్కడ కనిపించాలి. యా, అంటే
సార్ స్క్రీన్ కొంచెం అప్లోడ్ చేయరా?
ఏంటండి మేడం? స్క్రీన్
కొంచెం అప్లోడ్ చేయండి. థర్డ్ 2Z ఉంది కదా సార్, కొంచెం పైకన్నా.
ఓకే, యు హ్యావ్ క్వశ్చన్?
Yes, okay sir, thank you sir.
Now I'm taking that problem. It is a set question. The number of zeros of the polynomial, number of zeros of the polynomial z power h plus 10z power 3 plus 14 that lie in the domain 1 less than modulus of z less than 2. నేను ఇంటిస్తాను ప్రాబ్లం విచ్ చేయాలి. is first option 5, second option 6, third option I think it is 2017 set 7, and the fourth option is h. Okay, 1 less than modulus of z less than means it is a annulus of region bounded by 2 concentric circles of center at the origin. This is the origin. Okay, first circle radius r1 is equal to 1 and second circle radius r2 is equal to 2. Okay, to e region though we have to construct the zeros. How many zeros we have? Okay, first z power 8 to 10z cube 14 ఇలా ఇండివిజువల్ గా తీసుకొని మీరు చెక్ చేసుకోండి. z power 8 z power 10z cube 14 లేదంటే మీ ఇష్టం ఎలానా తీసుకొని చెక్ చేసుకోవాలి. కండిషన్ ఏంటి? మాడ్యులస్ ఆఫ్ f of z ఈస్ గ్రేటర్ దెన్ మాడ్యులస్ ఆఫ్ g of z, లేదంటే మాడ్యులస్ ఆఫ్ f of z ఈస్ లెస్ దెన్ మాడ్యులస్ ఆఫ్ g of z. మాడ్యులస్ ఆఫ్ f of z గ్రేటర్ దెన్ మాడ్యులస్ ఆఫ్ g of z అయినప్పుడు నెంబర్ ఆఫ్ జీరోస్ ఆఫ్ f of z ఫైండ్ అవుట్ చేసి సరిపోతుంది. మాడ్యులస్ ఆఫ్ f of z ఈస్ లెస్ దెన్ మాడ్యులస్ ఆఫ్ g of z అయినప్పుడు మాడ్యులస్ ఆఫ్ g of z జీరోస్ ఫైండ్ అవుట్ చేసి సరిపోతుంది. ఓకే, యాజ్ యువర్ విష్, మీరు ఎలానే తీసుకోండి. ఓకే, తీసుకొని మీరు చేయండి. ఇట్ విల్ బి దిస్. సో దిస్ ఆల్మోస్ట్ వి కవర్డ్ ఆల్ ప్రాబ్లమ్స్. అండ్ ఐఎమ్ లివింగ్ వన్ ప్రాబ్లమ్ హియర్. ప్రీవియస్ గా మీకు ఒక ప్రాబ్లం లింక్ చేశాను, ఆ తర్వాత చూద్దాం చెప్తాను. The Lorentz series expansion the Lorentz series expansion of f of z is equal to z square minus 1 by z square plus 5z plus 6 about z is equal to 0 in the region, that is about z equal to 0 in the region 2 less than modulus of z less than 3 is. I'm not taking options, just I'm explain the problem. F of z is equal to, we can write z square minus 1 by factorization of these two terms here. 1, 2 plus 3, okay. Z plus 2 into z plus 3. And numerator also, we can write z minus 1 into z plus 1. Okay. So we can expand the terms like first I am writing z plus 2, replace z equal to minus 2 here, minus 2 plus 3, here minus 2 minus 1, minus 2 plus 1, first term. Second term, z plus 3, minus 2 plus, sorry, minus 3 plus 2, okay. Here minus 3, minus 1, minus 3, plus 1. So here, numerator is minus 3, minus 1. This is 3. Denominator is 1 only, z plus 2. Here, minus 4, minus 2. This is 8. Denominator is minus. So it will be minus z plus 3. Okay, ఇలా మనకు ఇలా ఎక్స్పాన్షన్ చేసుకున్న తర్వాత ఇక్కడ కండిషన్ తీసుకోండి. కండిషన్ ఏంటంటే 2 less than, కండిషన్ is 2 less than mod z less than 3. ఇందులో 2 parts గా డివైడ్ చేసుకుంటున్నా. 2 less than mod z. So 2 by mod z less than 1. That means 2 by mod z less than 1. First condition. And mod z less than 3 అండి. మనకు లారెంట్ సిరీస్ ఎక్స్పాన్షన్ అడిగారు కాబట్టి నెగటివ్ టర్మ్స్ కోసం తీస్తాం. రెసిప్రోకల్ తీస్తాం. Greater than 1 by 3. So డైరెక్ట్ వచ్చేస్తుంది కదా, అవసరం లేదు. ఇక్కడ ఒక టర్మ్ అయిపోతుంది. ఇక్కడ అనలిటిక్ పార్ట్ ఉంది, ఈ ప్రిన్సిపల్ పార్ట్. జస్ట్ ఐఎమ్ రైటింగ్ mod z by 3 less than 1. That is modulus of z by 3 less than 1. అంటే we have to convert the function in terms of 2 by z and 2 by z and z by 3. ఈ ఫంక్షన్ లోకి మార్చు. So what we have here, minus 3 minus 1, this is 3, minus 4. So we have to write the function. Therefore f of z, I am writing again function 3 by z plus 2 as this. 3 by z plus 2 minus 8 by z plus 3. 8 by z plus 3. Okay. So 3 divided by, I am taking z common here. 1 plus 2 by z. Here 3 common. We can write z by 3 plus 1. So here 3 by z of 1 plus 2 by z whole to the power of -1 minus 8 by 3 1 plus z by 3 whole to the power of minus. Okay. So I'm writing 3 by z as this expansion of this 1 minus 2 by z plus 2 by z whole square minus and so on. First term, second term minus 8 by 3, 1 minus z by 3 minus plus z by 3 whole square minus and so on. Okay. So this is equal to 3 by z, this is minus 8. Okay. 3 by z summation n is equal to 0 to infinity minus 1 to the power of n. 2 by z whole to the power of n. Next term minus 8 by 3 summation n is equal to 0 to infinity minus 1 to the power of n z by 3 whole to the power of. So we can write it as 3 into summation n is equal to 0 to infinity minus 1 to the power of n into 2 power n divided by z power n plus 1. First term 8 into summation n is equal to 0 to infinity minus 1 to the power of n divided by 3 power n plus 1. Okay. Into z power n here. Okay. Clearly we can observe it is a analytic part, and it is principal part. Okay. Okay, mana problems we kaniపించిన will discuss later also. Okay. Almost I have covered all the problems. If you have question, you can ask. Yes.
Yeah. Any more questions from your side?
సార్ నెంబర్ ఆఫ్ జీరోస్ లో ఎట్లా తీసుకుంటున్నారు సార్ f of z g of z అది
అదేనండి మన కండిషన్ ఎలా అంటే ఈ కండిషన్ వచ్చినట్టుగా తీసుకోవాలండి. either modulus of f of z greater than g of z or f of z is less than modulus of f of z greater than modulus of g of z or modulus of f of z is less than modulus of g of z. లేదంటే ఇంకో కండిషన్ కూడా చెప్పాను, modulus of f of z by g of z less than 1 అయ్యేటట్టుగా మనం చూజ్ చేసుకోవాలి. చూజ్ చేసుకున్న తర్వాత ఇక్కడ ఏంటంటే ఏదైతే ఫంక్షన్ చూజ్ చేసుకున్నామో మాక్సిమం వాల్యూ ఉందో దాన్ని జీరోస్ చెక్ చేసుకోవాలి, ఇన్సైడ్ అవుట్ సైడ్. ఇంతకుముందు మనం ఒక ప్రాబ్లంలో అదే చేస్తాము. ఇక్కడ మనం ఏంటి f of z ఈక్వల్ టు z పవర్ 5 3z3. దీనికి పర్టికులర్ రూల్ అంటే ఏం లేదు, మన కండిషనే ఇది. modulus of f of z is greater than g of z కండిషన్ అయ్యేటట్టుగా చూజ్ చేసుకున్నాను. చేసుకుంటే ఇక్కడ మనకేమొచ్చాయంటే ఈ కండిషన్ వచ్చింది కాబట్టి f of z జీరోస్ ఫైండ్ అవుట్ చేస్తే సరిపోతుంది. ఆ f of z జీరోస్ ఇన్సైడ్ ద సర్కిల్ ఉన్నాయా లేవా చెక్ చేసుకోవాలి. ఫర్ ఎగ్జాంపుల్ నాకు z ఈక్వల్ టు 0 0 0 ఇంకొక 2 రూట్స్ ఇలా వచ్చాయి, 3 and 4 అనే వచ్చాయి అనుకోండి. ఈ 3 and 4 ఇన్సైడ్ ఉండవు. ఇక్కడ చూడండి, ఈ 0 2 ఇక్కడ నుండి ఇక్కడ వరకే ఉండాలి, -2 to 2 ఇక్కడ వరకే ఉండాలి జీరోస్ అని. ఇక్కడ మైనస్ ప్లస్ ఆర్ మైనస్ √3i ఇన్సైడ్ ఉంటుంది. ఓకే, 1.732 ప్లస్ -1.732 మైనస్, ఈ రెండు కూడా ఇన్సైడ్ కాబట్టి
చెక్ చేసుకో. 3 zeros ఉన్నాయి కదా సార్, 5 zeros టిక్ చేసి.
అవును సార్, 5 zeros కదా, 1 2 3 ప్లస్ మైనస్.
ఓకే ఓకే సార్,
ఇక్కడ రెండు మొత్తం 5 zeros. ఓకేనా? ఆ కండిషన్ వచ్చినట్టు మేడం, అవి మీరు కండిషన్ ఇది ర్యాండమ్ గా మనం చెక్ చేసుకోవడమే, మనం డిఫరెంట్ వాల్యూస్ తీసుకొని చెక్ చేసుకోవాలి అంతే. ఓకేనా? ఎనీ క్వశ్చన్స్?
సార్ ఇంత ముందు చెప్పిన ఈ ప్రాబ్లం తర్వాత ఒకటి ఎక్స్పాన్షన్ ఎక్స్ప్లెయిన్ చేయాలి.
ఇదా
నెక్స్ట్ ప్రాబ్లమ్ సార్, నెంబర్ ఆఫ్ జీరోస్ ఫైండ్ అవుట్ చేసిన దాని దగ్గర.
ఇదేనా?
లేదు సార్, మనం అంతకుముందు ఒక
Problem
yes sir,
చేసామా?
this one sir.
This one. Yeah.
Yes sir.
ఇది క్లారిటీ కొంచెం కన్ఫ్యూజ్ అయ్యారా? ఇంకా అనుకున్నాను.
Yes sir.
Actually, I'm writing sin
ఇది
2z as
ఇంతకుముందు చూపించింది mod
problem
0 less
ఓకేనా?
than mod z less than 1 ఉంది చూసారా సార్? అది
0 less than mod z less than 1. ఎక్కడండి?
అది హోంవర్క్ ప్రాబ్లం ఇచ్చారు కదా సార్, అది.
ఆహా, ఓకే ఓకే, మీరు టైప్ చేయండి మేడం, వస్తుంది అది. జస్ట్ ఇక్కడ
ఓకే
మీరు
ఓకే
ఏం
సార్, అది నేను నాకు
ఓకే, నేను
నెట్వర్క్
చెప్తాను,
ప్రాబ్లం
నేను
వల్ల
ఏంటి
మీరు
ఇస్తాను.
హోంవర్క్ అని చెప్పింది అర్థం కాలేదు.
ఓకే, మీరు ఏం చేయండి అంటే ఎఫ్ ఆఫ్ జెడ్ తీసుకోండి, ఏదన్నా మీ ఇష్టం. జెడ్ పవర్ నెగిటివ్ పవర్స్ ఉంటే లారెన్స్ సిరీస్, పాజిటివ్ టర్మ్స్ పవర్స్ ఉంటే టైలర్ సిరీస్. దిస్ ఇస్ ద కాన్సెప్ట్. ఓకే సార్?
ఓకే సార్.